This is programming in assembly. Like a man once said, assembly is hard as f. But if you're not ready and scared of doing hard things in computer programming, you should probably just leave it all together and transcend to farming. In this video, we're going to make a program that compares values from a given memory location and selects the greatest value of all of them. Start out by writing section.data, which is the place where we will declare all the variables we need. I'm adding an array of numbers which I'll be comparing from. If you want more headaches, then you can probably accept the numbers from user as well. Just remember to convert those from ASCII hex to normal hex, which is what the H denotes after each of the numbers in the array. After that, I've defined a few generic statements so that the program is more presentable and user-friendly. I would suggest you do these as well as it's a good practice. In the section.bss, we define a counter and greatest number called big no and a macro which we will use for reading and writing. Now we'll write section.text, which is where the actual logic will be written. Start by global underscore start followed by underscore start and display the elements present in the array to the user. If you're accepting elements from the user to compare, this would be a place to ask the user to enter 5 numbers or whatever you want. The label back and the statements after it until the J and Z or jump if not 0, basically a loop for displaying all the numbers. I won't be explaining this in detail as we've already covered it in our first video. If you haven't watched it, click the info card in the top right corner. You might have noticed a statement mentioned as call display. This is a function or procedure which converts hex to ASCII hex. I believe we've already done this in another previous video, but I'll be explaining this again as it's pretty important to be known thoroughly. Now in this block of code, we basically write the output message for the greatest number and start the process of comparing every number from the start with each other. First, we move 5 to a counter variable CTR. Then we move the contents of the array into general register B or RBX. Then we initialize the accumulator RAX by using the superior method called XORing it with itself. After that, compare the contents of AL, that is accumulator, with the contents of RBP. According to the sequence that is mentioned here, if the value in the accumulator is greater than the element RBP is currently pointing towards, then the JA or jump if above statement will be true. The jump if above statement is used only for unsigned values though. So if you're using negative numbers, consider using jump if greater or JG. In any case, both of these statements are pretty similar, so use them accordingly. We will now move the greater element of the array, which RBP is pointing towards, into the accumulator. And if the number happens to be less, then we won't do anything as we don't care about the smaller numbers. In the next label, we increment RBP so that it can point to the next element of the array. The counter needs to be decremented as well. Then we'll add a jump if not 0 so that the loop will keep on running till the end of the counter. Now the required number is present in the accumulator itself, so we can call and display the value. After doing this, we perform the exit system call, which is basically moving 60 to the accumulator, 0 to RDI, and using syscall to call your. That's it guys, thank you for watching. I was just kidding, that's not the end of the video. Here's a detailed explanation of the display method. First, we move the content of RAX into RBX, which is base pointer. Then we'll take 16 into register CX, as CX is going to be our counter. Then we make the RSI or source index register to point towards big number. And now we rotate the content of RBX, which contains the greatest number from the accumulator, by 4 towards left. And we move the content of the least significant 8 bits of B to register A. This basically means that we are moving the rotated digits to the accumulator. Now we are going to perform AND operation with 0FH and the accumulator. This will mask any other digits except the LSB. Then we shall compare the accumulator with 09HF. The number is less than 9, then we will add 30, and if it's greater, we shall add 37 to it. Basically, by adding 30 or 37 to the hex number into the we are converting it into the corresponding actual number according to the ASCII convention or ASCII convention. So after doing the addition, we move the contents of the accumulator, which are basically 2 digits, to the big number or RSI pointed location. Then increment RSI by 1 and decrement counter CX. Now we are pretty much done. Just another back rotate conditional jump and a call to the read and write macro to print the greatest number and another print statement for new line. There you have it, guys. The display function in all of its glory. Also, please don't forget to write the RET instruction, otherwise everything will just fall apart. That's all. Now let's compile and look at the output. Here you go. The greatest number out of all of these is 9, and as you can clearly see, the program is showing 9. Now I'll change the numbers a little bit so that you believe me that I am not lying and this is not just some conspiracy theory made by the aliens from Area 51. We'll run the program with the new numbers, and here you go. The greatest number is 91 out of the mentioned. Here it is. Thanks for watching and keep practicing. See you in the next one.